2. And check, check. Okay, so we're good there. All right. Okay, so what I wanted to do today is sort of give an overview of Blender, what it is and kind of like how it works together. Because one of the key things that I want to talk about is that they're both Blender and Unreal are very general. They actually have some systems that overlap with each other, but they do have some differences, and knowing how to use which one at the right time is like just as important as how to actually use them. So a little bit of background about my experience with Blender. I've actually been using this program since like 2005 or so. So back when it was really rough with the interface, before it didn't support it didn't support multi-threading or any, and the interface was extremely hotkey driven. So Blender's history, I mean, looking at it now, it's a super slick tool. The user interface is actually really nice. It's pretty explorable in a way that was not like that at all. So back in, say, 2005 or so, it was not really even seen as a major contender to things like Maya and 3D Studio Max, where it is now, because at the time it was such a rough tool, and that was actually it had a major image problem, in my opinion. So Blender's original inception was as a professional tool. It's not like a lot of other open source projects which start as like a hobby and then it sort of grows from there. It actually was started as an in-house tool by a very small production company. They eventually went out of business, and so their assets fell to an insurance company. But then one of the former employees raised some, I think it was 2002 or so, he did a crowdfunding project in order to release Blender as open source because it was kind of his baby and he wanted to continue it working. And because of that, in my opinion, Blender becoming open source was really massive. And you're a computer science guy, right? No? Are you familiar with like the story of the Linux kernel or even things like that?
I think
Okay.
I'm somewhat familiar with the story.
Okay, well, it's a great story, but one of the things that's crazy about it is that open source as a culture is really unique. It's really driven by like these ideological underpinnings, mostly written by Richard Stallman. Um, who now is kind of a libertarian. He's kind of also had some issues with being canceled for standing up for Jeffrey Epstein in sort of a convoluted story. But the idea is that, it has ideological basis, which kind of defines it. And it's very, generous and, emphasizes things that you can do. But anyway, being an open source program really has impacted Blender a lot because you have the authors of it that have their vision, how they want things to work, and some ideas are weird. But then you also have other contributors and things like that that have different complaints about it. And other programs, like say FFmpeg, have all kinds of drama that results in forks and just, or it just chills collaboration and things like that. But one of the key things that I want to talk about is Blender is really like one of the best examples of that happening open source. So this is a photograph I took of Ton Rosendahl, who's the lead developer behind Blender. This is a photograph I took at SIGGRAPH 2019, which is a big mega conference for computer graphics, right? He had a panel of like a Blender sort of status report for everybody, and it was the way they did all of the other conferences were they set up like a table in the front and there was like a panel discussion with some microphones and they give a presentation and it's very much like top down, we talk to the audience, right? But seeing like how he conducts himself and how he just like organizes people massively impressed me. So one of the things that he did was that he was actually committed to just like facilitating discussion and collaboration even within this stage he was given. So there was this microphone in the back that was designed to do it for be there for an audience Q&A. And he actually like ripped up the microphone cable so he could walk around and have everybody in the room just talk about what they use Blender for. And it wasn't just him like, he did it because out of a sense of genuine curiosity, because you could tell that he really knows Blender, but at the same time, it's a mystery to him what people are actually going to do with it. So he gets so much energy from being surprised by the things that people use it for. And I'm just like super impressed with him, like not just as a programmer on a technical level, but just like as a leader. So Blender itself is really, I mean, a great program. And within the way I use it here at Marquette, it's almost like if I can solve a problem with Blender, I try to do so as much as possible, just because it's, in a sense, there's just so much pride in how it is put together and how it works. One of the great emphasis of that is their release logs. If you even go back to their older versions here, these come out like it used to be every 6 months, now it's like every 3 to 4. And the amount of stuff that they've just packed in there, like just in the past, 3 months, is just bonkers. No other, even other program in the industry, or even other professional tools of any category have release logs like this. They're just throwing in so many different things all the time. All of it is super impressive. And there's a lot of parallel teams working together for it. So even though this is just the latest one, even spent some time going back, even to 2.8 was the first big overhaul of the user interface. And since then, that was sort of a turning point where things got really picked up. 2.79 coexisted with 2.8 for a long time because 2.8 was a major overhaul, despite the tiny increment in the version numbers. Blender's version numbers are super kind of frustrating because Google Chrome is something on like version like 90 or something like that, and they bump up the version number every time. But for Blender, it's like 3 years of work and they go from 2.79 to 2.8. It's extremely rare that they bump up a major release number. So even when I say I was using it in 2005, 2006, that was version 2.3. And it looks completely different. If you go back to like 1998 or something like that, it was version 1.8. And it's completely like unrecognizable. People do challenges where they try to download version 1.8 and do like anything in it. And it's challenging because everything you're used to is gone. Okay, so let's talk a little bit about how to use this. One of the core things about Blender, I guess the basic difference between what Blender does and what Unreal does is that Blender can make movies, it can do physics and simulations and things like that and renders, but we're going to give all of those tasks to Unreal. And the role of what Blender can do here is going to be really limited. We want to focus mostly on modeling. And by modeling, I mean creating assets or actors that are going to go into the Unreal scene for manipulation there. Blender, for example, if you're making a character, you can make things like hair on your character using a particle system that's built in here. You can set up lights and do like rendering and things like that all in here. But even when it comes to doing some stuff with texturing, all of that will probably have to be done over again in Unreal. So just have that in mind and don't even really bother with it. I'm going to be for future reference, if you want some additional tutorials about of how to do things, there's two websites that I recommend. One is cgcookie.com, and the other is Blender Guru. Both of these are moderate length YouTube tutorials. But again, focus on the geometry of the objects. Once they get to texturing or doing stuff with nodes or cycles, which is the rendering engine, just skip it, don't even bother it. All right. So the other thing that's different between here and Unreal is the terminology and the vocabulary that you need to know is a little bit more closer to the metal than what Blender or what Unreal will do. So the manual, which is the website here, docs.blender.manual, actually is pretty good, and it explains a lot of things as well. But here's some general rules that are universal. So when it starts up, it looks like this. This already looks a lot like Unreal because of the dark theme, because of the hierarchy list up here, and because of the properties over here, right? So Unreal is set up in a pretty similar way. This thing down here is a timeline that's used for an animation, if you're having animation. But one of the things that's really important here is that everything in Blender really consists of one type of window. Or basically this simple rule that there's a header at the top that has some menus, and then there's a drawing area. Some menus will have bars on the side. Like there I pressed N to flip out this that has some properties, and then the other one is T. If you don't remember that, it's always shown up here too. This little thing right here is really important because when I say everything that this program can do is a combination of just different window types, this is what I mean. There's a lot of different just types in here. And these tabs here are just previews for different types of tasks. And if you want to like split one, you can right click on a window pane, hit horizontal, vertical, split it, and that'll split a window. If you want to turn this into another 3D viewport, you can do that. If you want to put a spreadsheet or a text editor, here you can mix around these layers. These can be joined together any way you want. And anything can be turned into anything. So I tend to mostly keep it to the defaults, but if there is a task where I need to look at something close up and far away, I can split the view like this, or I need to have it in isometric over here and like that over here, or you can mix around anything. These are only presets. These can be renamed and all that. So I'm not doing animation, so I'm gonna right-click Join Area to get rid of that. The other thing to remember about Blender is it's really modal. As in, it's really important what mode you're in and what you have currently selected. So when you're in 3D view like this, the two ones that we'll use the most are object mode and edit mode. So let's talk about object mode first because it's simpler. In Unreal, you can grab and rotate scale of objects. Here it's the same thing. You can turn on a widget if you want to actually control things like with that, but or a gizmo. But I never really use this. I find it's in the way more often than it's not. I tend to memorize a fair amount of key shortcuts and actually keep your hand on the left keyboard at all times, because when I say it started as a development tool, like an in-house professional tool, that still has some legacy because it's made to be used by somebody who's trained in it, somebody who does it all day and really cares about speed and efficiency. So Blender is more discoverable than it used to be, but knowing the shortcut keys is really the intended. So pay attention to this little bar up at the top right here, okay? If I press G, that's for grab. Now I'm moving it on a plane that's basically perpendicular to how I'm viewing it, right? So right now, I'll split this, actually, you can see it from the top. And I'll look at it from the camera's point of view. I hit G and move it. I'm moving it on this ellipse that's perpendicular to the camera that's right there, right? If I look at it from the top and hit G here, I'm moving it on the planes that are perpendicular to that, which is X and Y. So there it's staying on the same height. So the view that you're looking at, it matters. So I use the keyboard shortcuts a lot to pop around between different views. I'll use on the number pad, the numerical number pad. 7 is top, 1 is front, and 3 is right. Also, if you press 5, that toggles between perspective and orthographic. I mean, perspective meaning, you know, things get bigger as they get closer to you, of course. And perspective or orthographic means everything is aligned to a grid, and perspective never converges. So if I'm moving something and I hit X, Y, or Z, you see it draws a red line or a colored line there. That means it's constrained to that axis. So if I want to move something only in one dimension, I can hit G and then X or Y. And if you look up here in that status bar at the top, you can tell what it's doing right there. Global Z. And also, you can tell which one is which by looking at this. Also, it's universally consistent that X, Y, Z is red, green, blue in that order all the time. Okay. If I hit G and then Shift Z, then it says up there locking global Z. So now it's moving on X and Y, but not Z. And also I can hit X, Y, and then I think, well, actually XX is local X. I'll get to that later. Okay, so rotate and scale work the same way. If I hit R, it's rotating it on a pole. That's that dot right there. Like picture that dot as being a pole that's pointed straight at me. If I hit X, it'll rotate on X. And Y is just like that. Or actually, no, that's Z. Oh, one more thing. You'll notice this plane here, this is the floor. And if I move it up off the floor, that's moving up in Z. In Unreal, up is Y. So the whole scene, stuff gets imported by 90 degrees by default. And the reason is kind of a dumb story, but it's basically whether you think of the third dimension as being like laying on a piece of paper on your desk, and then Z is up off the desk, or if you're looking at like a whiteboard or something on a wall, then X and Y is along the wall, and then Z is off the wall. So that's the difference. Programs that come from different industries that are more desk or wall based, whether they use blueprints or chalkboards, really defines what they use as an axis convention. No, when you export a file, it'll correct a rotation for you automatically. If you're writing code, you may be manipulating the variables directly, and that could cause a problem. Okay, so one thing is local coordinates. I'm going to make this irregular, okay? Now, if I hit G, X, or GZ, that's global right there. If I change this to local, you'll see now the orientation of that widget is matching the orientation of that object, right? So if I hit GZ, that's local Z. Did local first because I have it selected here. But you see global Z is up and down, and then local Z is perpendicular to its faces. Okay, so also I can see the rotation of the object here. And if I hit Alt-R or Alt-S, it'll set those back to the default, or Alt-G to put it back. So G, grab, rotate, scale both have clear, rotate, clear, grab, clear, scale. That'll be more important later. Where I left off was object mode. Well, anyway, the whole point of object mode is if you have multiple objects, grabbing them selects the individual object and moves them around by their origin. If I rotate them, it's spinning them around their origin, which is that center point, right? If I go into edit mode, now I can select the parts of that object, which in this case is the vertices. And I can grab and move around the vertices. Now there's also these two little buttons up here to say what am I selecting? An edge or a vertex or a face. Again, that's from this diagram. If I select a face, I can rotate that or grab it or scale it, and I'm starting to put together the object. There's all these sort of functions in here that can do things to that. One of the more important ones is extrude faces. That allows me to add vertices. And if I just do the simple technique of using just what I've shown you for grab, rotate, scale, you can still make like decently interesting shapes just using that, you know? So when it comes to putting objects in your scene, I feel like in Unreal there's this tendency to, for especially starter projects, to take all this preset content, grab stuff from the marketplace, throw it in your project, and you end up having a whole mishmash of art styles and code that you didn't write. But I mean, if you're making your own project and you want to have, you know, unique, consistent style, if you want to have your main character be something that's unique to you and you design it yourself, you know, in a lot of cases, you can do that in here to create objects for your environment, to create little pieces that you would then assemble and to form your levels. That said, there are things like in Unreal, there's a character creator built in called MetaHuman. If you want to make a realistic human, it's pretty easy to avoid duplicating work by using something like that. But if you wanted to create something from scratch, like an object, like I have a scene where I needed I don't know, a building made or something that I don't want to just kit bash it together. So anyway, now I want to talk about modifiers because this is a really cool thing. So I'll take this shape, which again is just, you know, a cube a minute ago. I can add a fair amount of other steps to it called the modifiers, and they can do some pretty interesting effects on it. And you'll probably get to know some of these, like mirror is especially useful. Talk about geometry nodes later. Subdivision surface and decimate are also pretty important too, but I just want to show you subdivision surface, for example. So it's really easy to make organic shapes like that by subdividing and then sort of averaging out those few vertices that I have. And I'm in object mode right now. if I go back into edit mode, you'll see that my original mesh is still there. So what modifiers do is that they'll take my basic in mesh, the vertices that I have laid out in here as an input, and then modifiers will run it through a series of algorithms in order to create, new shapes. And because I have these checkboxes on, I can see what those do as I edit. So I'm seeing a result of a subdivision mesh, but I still get to edit the low division mesh. Now, if I apply these modifiers, which I can do right here, then it takes what that modifier did and bakes it into the mesh. So now I have my vertices like this, and I can't really edit it as easily as I did before. So being smart with modifiers is kind of an important thing to understand. Well, you can undo it. There are also, one of the modifiers in here under decimate is unsubdivide, which is sort of getting back to where you were, but it's not exactly the same thing. But I got it back just by undoing it. A lot of them are generally destructive, or some of them you can fix manually. Now, if you don't want to start with a cube, there's also, under here, there's different objects here as starting points. Circle or UV sphere or icosphere is really important. One of them that you want to pay attention to is that when you first create an object, there's this little menu down here that has some parameters for it. For example, if you make, actually, the sphere is a better example. So there's the default sphere. If I wanted to make it higher resolution, I can increase these numbers here, like that, and it's just subdividing it. That really clearly here. If you want to make a triangle or a hexagon, you can make a circle and then set it to like 6 sides. So these kind of things are sort of important. Also, you can control the position and rotation in some of this initially, but changing the segments in the rings are not too difficult, are more difficult to add later, especially with a sphere because you want it to be on a perfect curve. Okay, so there's a lot more to modifiers, but I want to talk about object origins. This is something that is a common mistake. If I'm in edit mode for a cube, I can still select all of the vertices and grab and rotate them, right? But the object's origin is still there. And if I rotate it, it's still rotating around that point, which could be off-center. Now this will create a lot of problems if you're trying to animate this later on, or if you have, sometimes if you have a physics collider on it and the object's center of mass is outside of the object's boundary, things can get a little chaotic. So pay attention to what you're doing. So for example, this cube here, it is still a normal cube in the sense that it has its faces are still aligned. Let me clear rotation on this one, and you see now like the local axes are skewed. Whereas this one, if I clear rotation now, it's correct. That's because I can look at the options here in rotation mode here. I mean in the window here and see the numbers there. I can also change them here. Also, you can apply these values. For example, if I wanted this cube to be skewed like if I wanted my cube to be sort of a floor, actually I'll just start over. Now the scale for this is pretty weird, right? It's -18, -18, 0. If actually, I think it's too complicated to explain why, but under here there's apply scale, and now the scale is set to 1.0, which means those vertices are the same in both space. That's useful sometimes too. If you have an object that's skewed, that has a non-normal scale, applying scale before you export stuff into Unreal will avoid some problems. But you can also apply rotations. For example, this object, after I added that detail, I turned the object around and I want it to be sort of pointing up like a tree, like that. But the object's actual rotation is pointed that way. So I can clear these numbers and bake them into the vertices by applying rotation. And now when I rotate it, you know, it rotates nicely. I can also, you'll also notice it rotates from that point at the bottom. If I want to rotate it from the middle, what I want to do is set origin. And there's a couple options here. Origin to geometry works pretty well most of the time. Origin to center of mass or center of volume are just more complicated versions of that same thing. And that puts the object right there. This also is, again, a matter of style, in a sense. If I'm making objects like, say, trees that I want to be anchored to the ground at all times, I'll put the anchor point on the ground so I know in Unreal I can always put the object's position at 0 and it'll be on the ground and not halfway through the ground or something like that. So I guess I'm just, I know I'm jumping around, but that's best practices are really important. Okay, so there's also other completely different ways to model things completely. One of the nodes in here is called geometry nodes. And that actually doesn't, you'll notice there's no controls here because it actually has this whole section in here. And this, you'll notice, you know, kind of looks like blueprints in a sense, right? You have a simple node where you can take it's a modifier, so it takes the vertices that you set up here and it runs them through all kinds of filters. Some of them you can even generate additional vertices, do all sorts of functions in here. And the advantage of doing it this way is that everything in here is a pipeline that you're creating, so it can be non-destructive. You can have it start with a cube and turn it into completely complex objects. In fact, like one of the things that they showed you in the new version, because this is one of the big things they added in 3.0, was yeah, things like this, where the input is super simple. So all of these functions about extruding and scaling and all that are all done through nodes, which means that they can be changed and reordered at any time. It's a little bit more, you know, abstract if you're not familiar with what the tools are, but there's a lot of potential for making stuff that's permutations of things. Like in this example down here, like this house was actually built completely out of nodes, geometry nodes. So you can modify, like, say, the height of the building as a parameter, and it's not baked in. It's pretty bonkers stuff. This is a pretty new way to do it, and it's sort of a completely alternative way to do it than this polygonal modeling. The other way to model in Blender is called sculpting. Or actually, I'll go back to modeling. And sculpting is another mode that's here. And that gives you a series of what are brushes here. Now, sculpting, I think, has really also opened up the door to a completely different way of thinking about how objects are made in Blender. It's also opened up the door to a very different kind of audience, because people that are interested in geometry nodes, um, there's very little overlap with those people and those people that want to do sculpt. Because sculpt turns this into what's basically like a piece of clay. And you can, inflate and cut and do all of these like little functions. Here, I need to subdivide this a little. So this can be done with symmetry or other functions, or all of these put together. Grab. So, I mean, like I said, think of it like a piece of clay. This is kind of a terrible example, but you really just, manipulate the object. Different brushes. It works really well with a touch screen or a tablet or something too. And if you wanted to add other details, or even get your base mesh to be a very rough shape and then sculpt in all the details, that's a common way to do it as well. But that's another cool way to do it. But again, make sure your origin is back where it should be. Make sure your scale is appropriate. And should also mention this other part in the interface here. So a lot of these are functions for different properties of how things are of the object here. Some of them will be available or disappear when you're in edit mode or not, but mostly it's consistent. So the way texturing or shading works in Blender is done using, again, a node-based system, which is a lot like Unreal. But I wouldn't spend a whole lot of time in here. I would really just set up maybe some base colors, use it to generate some textures. The lighting it gives me is just a default so I can see something, but I'm not going to change the lighting. What does matter is if I'm generating my own texture maps or general parameters, or if I'm setting up multiple objects. Like say if I made an object like a pen, like this pen, I would want there to be a smooth plastic part and then a rough rubber part and then a different eraser, maybe a graphite. So that's like 4 different types of materials. You would want to pick out which vertices belong to which material and then assign them in Blender and then figure out the actual material properties in Unreal. So things like that. UV coordinates. I don't know if I should get into that, but UV coordinates are pretty important. Just to give you an idea of what those are for. Oh, I need to put this into UV editor mode. Okay, so down there I have a cube, 6 regular sides. If I were to print that out, if I wanted to texture that consistently, I could think of this as being a piece of paper that I could cut out and then fold these pieces together to make a cross, right? And I could paint on a 2-dimensional surface, wrap that around a 3-dimensional surface, and the UV map is what tells me how, right? Now, if I have a UV map like a globe, right there, it's a little bit harder, but it's used because I used a UV sphere, it's going to follow the lines. And so everywhere on that 3D surface, even though it's deformed, still is going to fall on this. What about my little shape here that I made myself? Right. It still has, let me give you a better example. Actually, not that much. It's kind of a mess right now because it doesn't have anything. Let's put, okay, so that cube looks good. that cube looks like how things should. It's nicely mapped. I mean, it's pretty consistent. A little distorted, but you know, not too bad. I put that material on this. You see it's a little lumpy, but there's not that much distortion. But this one, remember I made that by extruding those faces, and now it's all kinds of stretched. And if I were texturing this, this would be a problem because I have a high amount of density of detail down here, but then this part's all stretched. So I need to make a new UV map. And one way to do that is under here, there's unwrap, which is pretty automatic. Sometimes it works. Smart UV project works all right. That takes the new shape and tries to, it basically like if there's a curve in the vertex on the edge that's over a threshold, it'll cut there. So smoother parts will form like patches like this. And as a result, even without doing anything, that looks much better. There's big seams right there, right where people are going to be looking at it, so I may want to do some manual stuff overriding it, but it's not that bad. Also, I can see B5, so that's over here. So if I pull these around, you'll see how that changes the map here, you know? And it always tiles too. I think it's overlooked that this is called a UV map. And map means it takes a point on the surface of the 3D object and it uses the map to find where on the image it should go, right? It doesn't know what correlates to what, so that's what the map is for. Doing UV mapping and texturing like this, or even just getting textures aligned in here is definitely Blender's job and not Unreal's. One thing that I really want to also emphasize, I'm going to start over just so I can make this one point, is there's a database system in here. So if I look at under here, this is a cube object, and this is a cube mesh, okay? I can duplicate, well actually if I go under here, there's two kinds of duplicate. Duplicate objects, duplicate linked. If I duplicate an object like this, now you see that they have different names and they have different meshes, right? If I duplicate them using the linked method, I have a new object here, but the mesh is the same as the first one. And as a result of that, if I edit this mesh, it stays synchronized to the others because they both are referencing the same thing. Whereas this is its own mesh, which is, you know, independent. This becomes really important once you have objects that are repeated, like in architectural projects. Let me show you something here. This is way beyond the scope of this class. The textures are going to come in broken, but don't worry about that. But if you have a complex object like this, one of the things that makes it look complex is because there's so many repeated patterns. But if you look at like this object here, I pull this vertex around, you see it's linked to all those other ones there. Same thing with this thing here, is that if I pull a vertex like this around, it's linked to all of those other instances. So GPU instancing really allows you to do more complex things, but having additional meshes really sort of, again, cuts ties to your ability to build progress. So one of the things that I like, so one of the fundamental things that got me into CG graphics originally was I I was really into caricature art. Like, there's certain artists, like famously like Al Hirschfeld or something like that, where they can take a pen of, yeah, or an inked brush and just do this one stroke that's just perfectly graceful. And that is just like, it's super expressive, right? And that stroke just takes so much knowledge to do. And once it's down, it's there, right? And I could not figure out how to do that because it's just the mastery of one single task that has to be right and then you're committed to it. But computer graphics for me were like a way to get into actually creating detailed and complex things because it allowed me to get past that. And what I mean is in computer graphics, I don't know how to make something. When you see something like this, you don't know how it's made. But you can see every little step and you can know how to improve it. And you can make 10,000 tiny steps in the right direction and incrementally improve tons of small decisions. So when I'm doing something with pencil and paper, the only way I can get stuff done is by doing like little pointillist, tiny little strokes all over. So I don't have a vast commitment to each one. I'm just building them up over time. And with Blender, it's the same way. So with Blender, it's like you can make all these little tiny steps that are incrementally in the right direction. And if you know the tools well enough, you're not burning your bridge as you go. You can always go back, tweak things, and just, build on your knowledge. And so that, I feel like, is the thing that makes the whole thing, the whole workflow, not overwhelming for me. Okay, so my point was, this is a mesh. If I click on it here, or this little icon right here, the mesh itself has some properties, including the location of the vertices. And then the object is I always get this wrong. It's this one. And the object has its own properties, including its general location and some other things about how it's displayed. So it can have its own rotation, but these are still linked. Okay, one more thing that you really need to make sure you do in Blender is name your objects, because this will get transferred into your Unity scene. And if you have a lot of them, or if you're trying to have a whole project, staying organized, housekeeping will really go a long way. So you can rename your meshes. It's not that important to rename your meshes. You definitely want to rename your objects so you know what they are. Otherwise, you're just going to have a lot of things that are all labeled cube, and your hierarchy is just going to become really complex. You can also, one thing I do a lot is create an empty object and then parent similar objects to it. So it's kind of like a folder. And let's see, I think that's I guess to wrap things up, just a couple closing things. Lights, you can position lights in Blender, but don't worry so much about how they're set up or what their intensities or colors are. They'll still show up in Unreal, but their parameters will be different. So how powerful a light is, it does not translate. Whether it's a point light or a sunlight will, its position will, but mostly I wouldn't worry about it too much. So if you skip lighting completely, that's fine. The way you export it is that there's a save your blend files in a separate folder outside of your project, and then export them as an FBX file. There's a couple different formats. OBJ is okay, but FBX should be the main format that you're using to export into Unreal. You'll notice the default setting here is Y up, not Z up. Also, you'll notice that under geometry, it will apply your modifiers and bake in the things like the subdivision surface into your vertices. That's okay here because you're sending it in one direction to the FBX file. If you need to modify it, if you want to make multiple versions or change something about it, go back to your blend file and then export your FBX file again. If you tried to import your FBX file back into Blender and then back into Unreal, that's probably going to create some problems, especially if you have modifiers involved or animations involved. So the blend file will still remain relevant.
So we got to make sure that the transfer is okay, uninterrupted.
Well, I mean, try to keep it in one direction. So
Okay.
you always have your blend file and you're going, the pipeline only goes from Blender to Unreal in that direction and not the other way.
Okay. So just keep it in one direction, not necessarily uninterrupted.
Right. The only exception I would make for that is if you're downloading stuff from the marketplace. Like say you have a character that's pretty close to what you want, but you want to like change a couple things about it. You want to change like some of the vertices around it. You downloaded a model of a crate or some kind of tool from there and you want to just redo the textures or make it gnarlier or whatever. From there you could take an Unreal object back into Blender and then sculpt on it or whatever and then bring it back into Unreal. But most cases you don't want to do that. Okay. Nobody said anything in the chat, right? So are there any questions or anything you're wondering about? Yeah. So, I mean, I know it is overwhelming, but I guess the bottom line is best practices really matter. Don't develop bad habits. Read the documentation. Watch videos.
Right. I get the
Yeah.
feeling that the best way to
You,
learn
you got to
is to
just do
just
it.
jump in.
Yeah. So the same thing with like the way you do blueprints in Unreal. Is like one of the things that you really need to do is, you're a chef and you need to know what the ingredients are. If you don't know like what garlic tastes like, you're not going to know how much to put in. And so knowing like what the modifiers are for or what the mesh edit tools, like the knife is really cool. You can subdivide things and there's all this stuff in here. Now, when I do Blender, I'm trying to be more visible, but to be honest with you, I push F3, which is the search. And if I want a tool, I type in something that I want and it gives me that function. Or I just hit the shortcut key because after time, you'll know what's in there. You'll know the shortcut key, and then you can just do super fast modeling stuff. I've attended Blender conferences where they actually have like speed modeling contests. They give you like a theme and like an hour, and they're just like, okay, at the end of the hour, we'll judge them. And the people who are good at Blender just put their heads down and just like blitz something together amazingly. And that's what I mean when I say it's a professional tool. It's not just some toy like wings or something, or things like that. So it's a blast. All right.
Yeah, that makes sense.
Also, one thing for my notes I forgot to mention. Like I said, I've been using Blender since like 2005. I've been using Unity since 2014, and I've been using Unreal for just like a couple months. And that's kind of a dangerous position because I know a lot about one thing, and then I come to Unreal and I have a preconceived notion how I think things should work, and I can be stubborn about that. So, I mean, you guys just need to know I'm a student too. I'm still learning Unreal as well. That's one of the things I want to do here. but I can be wrong about things. But a lot of it is just like, oh, in Unity they're called prefabs, in Unreal they're called actors, but they're kind of the same. Stuff like that. But still, I don't want to be I can still have fallacies of my own when it comes to thinking where things should be, or thinking what the right way to do things are. So, all right. So that's almost exactly an hour. Okay, so is there anything else that we want to discuss today? Um, this stuff is still, vertex count doesn't really become that much of an issue until it gets really high. Like, once you have, okay, so with old versions of Unity, if it's like say 8 vertices to be just a dumb cube, or if it's 65,000 vertices to be a reasonably low poly model of like an entire person, that's still one draw call. So it takes almost the same amount of time. Don't spend so much time like really micromanaging your vertices. With Unreal, one of the new things that's in version 5 is Nanite. Have you heard of this? No, that's Niagara. Um, Sort of. It's a way. Normally, normally, normally the amount of vertices you have does kind of have a limit. Like say 100,000 or so on an Oculus Quest. If you have more than that, you might have frame rate problems and things like that. So one things that video games have been doing for a long time is if something is really far away from you and it's only taking up like say 50 pixels tall on the screen, you don't need to have 100,000 vertices in that 50 pixel thing because they're all just too small to even show up. So they use what's called level of detail, which means it has a lower poly version of it that's for when it's farther away. And most of the time you can't tell the difference in the detail, but you can see it pop in sometimes if you get, as it transitions from one to the other. You might see this in video games too. But one thing that's new in Unreal 5 is it kind of handles that automatically. So if you have an object that's super detailed, like all of these scenes here have like, poly counts in the millions or so. As you get farther away from it or further from the camera, it'll basically like automatically reduce your models. Let me show you something like, I'll just bring in the monkey as an example. I'm just going to throw subdivision on here just so it's smooth, right? Okay. Now my wireframe looks like super tiny triangles, right? You can like decimate your models pretty quickly. All right. Depends on your art style. I'm just saying that you should focus, don't like just subdivide stuff too excessively. So what this does is that if you have objects that are excessively detailed, it'll automatically like retopologize them as you move around. So you can have high detail objects in your scene, and it'll like dynamically sort of reallocate vertices to them as they're more important and taking up more screen space. So you don't have to make really low poly versions. So this flickering that you're seeing as you move away is the engine like redefining the geometry on the fly. That's really what it's doing. One of the things like you can do in Blender here is, this is a mesh that was smoothed out, and then I ran a decimate filter in order to just chop down those triangles into just the ones that matter the most. The subdivision multiplies it by, 2 to the, or 10 to the 4th power, or something like that. It's exponential, and then decimate chops them down. So if I put 0.02, you'll notice that the mesh geometry changes completely. But the reason you don't want this as your key part of your workflow is because these triangles here are all really irregular. Some of them are really long and thin. They're not the same on each side. And so if you had to animate this, or if you wanted to texture it, there would be a lot of inconsistencies and problems that would cause. So that's why it's best to just keep your geometry clean when you're modeling. Clean, nice squares, quads for everything. Nice clean loops, no parts that are floating or intersecting. I mean, you can intersect if you want, it doesn't matter. Cleanliness. So, either way, things, like I said, if things get sloppy, you can optimize last if you want, clean it up once you get your concept down. Incremental decisions are the whole point, Yeah, all right. I'm gonna stop recording then. I think that's it for this week.